In these set of slides, I'm going to review experimental design, specifically focusing on independent group design and within group design. You might know independent group design as between groups, so keep that in mind. This is the same thing as between group design. There are different types of independent group designs, and here I have an illustration to help you visualize what this might look like. You're focusing on the participants. Actually, that's difficult to see on that background, but you're focusing on the participants, and I want you to notice that you have different set of participants in different environments. So let's say I had a study and I was looking at survival in different types of environments, and I would compare these participants on top to these participants on the bottom, right? So when you're dealing with independent group designs, you're comparing at least two groups, and they're experiencing two different conditions, two different levels of your independent variable. And keep in mind that they're not the same participants, right? Here you have, again, different participants. So they only participate in one condition of a simple experiment, right? A simple experiment would be 1 IV with 2 levels. So just to give you a better visual, the participants, so let's say here are the participants, and the color is supposed to represent different groups, right? You have a purple group, you have a blue group. So these are supposed to be different people. Keep that in mind. Then you have to place the participants, let me put it another way. The participants would experience only one level of your IV. So taking into account caffeine, they would only experience 5 cups, 1 cup, or decaf, right? So you'll see throughout your textbook they use condition A, condition B, right? So condition A, condition B to refer to the different groups. Sometimes they use level. Keep in mind that these terms are interchangeable in a simple experiment, meaning there's only one IV, right? So this would be group A, group B, group C, and keeping in mind that these labels are arbitrary, right? It's just something they're using to label the groups to help you keep track of the information. So you at least need 2 conditions with 2 levels, or you at least need 2 conditions or IV with 2 levels. Keep in mind, same thing in a simple experiment. And your participants only experience one condition. So condition A or condition B. Maybe I should have drawn them a little bit differently so you could tell they're different people. I don't know, right? These are different people. Keep that in mind. This one has a tie. This one has different eyes. I don't know. But the point is, keep in mind that the participants are only experiencing one condition in the experiment. Now, just to help illustrate what conditions and levels would look like in a more complex experiment, remember, a simple experiment only has one IV. Here's an example with 2 IVs, right? So when you have 2 IVs, here we have caffeine, time of lecture, and we have morning and afternoon as the levels for time of lecture, and 5 cups, 1 cup, 1 cup decaf for caffeine, right? So these are the levels for caffeine. We have 3 levels for caffeine, 2 for time of lecture, but we have 1, 2, 3, 4, 5, 6 possible conditions. The conditions are the situations your participants can be put into, that they can experience. They can either experience 5 cups of coffee in the morning, or 2, or I actually shouldn't have read that, or 5 cups in the afternoon, Or 1 cup in the morning, 1 cup in the afternoon, 1 cup decaf, right? Here's the decaf group, the control group. 1 cup decaf in the morning, 1 cup decaf in the afternoon. If you only had one IV, right? So let's say time was not an IV and only caffeine was an IV. Well, now we don't even have time. We just have 5 cups, 1 cup, or decaf. In this situation, right, the levels match up with the condition. So keep that in mind throughout the rest of the semester, right? That conditions and levels do match up in simple experiments, but for more complex experiments that include more than one IV, it doesn't match up, right? You'd have to, I would say, draw it out or think it through. But if you draw it out, you can create a visual that helps you think through how many conditions they actually have in that study. Now, post-test only design is one type of independent groups design. Now keep in mind, this is the same as between groups design. You've learned that using that term before, but here we're using independent group design as a terminology to refer to this type of design. But you have at least 2 conditions. Let me actually switch to the pen. Condition 1, condition A, condition B. It doesn't matter what you call it, but you have 2 separate conditions. Your participants only participate in one or the other. In addition, you need random assignment. Because this is an experiment, you need to randomly assign your participants to the conditions in your study. Now, you randomly assign, you have your pool of participants, right? These dots are participants. And then you randomly assign them to condition 1 or condition 2. And then you measure your DV. So if we were to use my favorite study, caffeine, decaf, anxiety, right? So I would place some people into the caffeine group, some people into the decaf group, not the same people, different people, then measure their anxiety, and then compare group 1 to 2 after, right? Based on their anxiety scores. This would be post-test only. They participate in the conditions and they get a measure of anxiety afterwards, or whatever your DV is. Okay, so thinking of this design, consider whether we meet the 3 rules of causation. Spoiler alert, yes, we do, but let me go ahead and show you. So let me make sure I have the pen, great. So can we detect covariance, or can we detect differences in the DV using my favorite design? Caffeine versus decaf, and the DV anxiety. Remember, we randomly place people into the caffeine or decaf condition. So I'm going to put or to remind us that. And keep in mind, this is an independent groups design, post-test only. So they're only getting caffeine or decaf. Now let's look at these requirements. So based on these requirements, can I detect differences in the DV? Can we detect covariance? In other words, based on this design, can I see how whether anxiety would be higher in the caffeine condition and how it would be different in the anxiety condition? So for example, actually I think a visual would help with this. Actually, I would expect the opposite of that. Let me get the eraser. So can I detect whether there's covariance? Yes, because here you can see that I can see when caffeine is introduced, how that varies, right? How the anxiety varies, and compare it what anxiety looks like when caffeine is not there. So let me put it another way. I can look at anxiety when the caffeine is there and look at anxiety when it's not there, right? Decaf actually does have some caffeine, but you know what I mean. You have the control group. So can you tell whether anxiety goes up and down when you introduce caffeine in this design? Yes, right? Because you have this control group that won't have caffeine, you have this group that does have caffeine, and you can say, well, it looks like when caffeine is introduced, anxiety goes up by 10 points. So you do satisfy this. Now, can I satisfy the second requirement that the IV come before the DV? Yes, because I'm going to do this first. I'm going to have them drink a cup of coffee and some decaf coffee, and then after that, measure anxiety. Check, right? So I've checked those two off in this type of design. Now, do we have control for other variables that might challenge our internal validity in this design? Well, I can, right? So for example, maybe I make sure that before I recruit my participants, they are not coffee drinkers. Just so I can make sure they're at the same level of their bodies respond similarly to caffeine. They haven't built up any tolerance to caffeine, right? I want to make sure they're equal in terms of that. So I'm going to recruit only people who don't drink coffee. Maybe I'm also worried about time. So you know what? I'm going to make them all go at 10 a.m. for everyone to make sure that time is not going to impact anxiety. I'm going to make sure temperature might not influence anxiety. But you know what? Maybe I want to make sure they all have the same type of researcher in terms of how friendly they are. I don't want them to get any more anxious by having somebody who's standoffish and possibly rude. So I'm controlling for all these other possible issues that might come up to have a strong internal validity. So I can check, in this design, I can check this off, right? I can check off this requirement. Depending on how much work you put into this, you might not be able to check this off, but this type of design does let you control for internal validity. Whereas if you were doing this in the environment, going to coffee shops, a lot of things would be out of your control, right? You wouldn't know, even if you asked, you wouldn't know people's tolerance. You wouldn't know what coffee, if that was their fifth coffee, what if that was like a particularly anxious day for them. And in experimental design, you can control for these type of things. Okay, so we went over this design, right? Independent groups, Postits Design. You have random assignment like any other experiment. You assign participants to condition 1, or, this is key, condition 2. Then you measure the DV. Okay, so let's move on to a different type of design. So in this type of design, it's still independent groups. Here are the conditions. They only experience condition 1 or 2. It's still or, right? They're still only getting one condition. We still have random assignment. The difference is that you're taking a measurement of your DV beforehand and after the fact. So in other words, you're getting a baseline, right? To see how anxious are they beforehand, what are their grades usually, how much sleep do they normally get, depending on what your DV is. Now, to just give you an example of this, let's say these were my participants, right? So I recruited it looks like I did a bad job in terms of random, in terms of sampling participants, but these are our participants. And in this type of design, I randomly assign my participants to condition A or condition B. Remember, condition A, my favorite study, coffee, decaf, right? And then I take a measurement of my DV, of anxiety. And this is what I find. Well, it looks like the people who drank coffee looked pretty anxious compared to the people who didn't. Now, if you were to think this through, what kind of issues could you think might arise in this type of design, right? Think about that. Like, well, for example, some people might be more tolerant to coffee, even if you did good sampling. People react differently to coffee. Some people have more extreme reactions. So even if you did a good job of recruiting people who didn't drink coffee, you might still get a difference based on an individual variation. So instead of using post-test only, that was that previous slide, let's use pre-test, post-test. Okay, so I recruit participants. This is what they look like before. Great. I can check and see that they're comparable before they participate in my study. If I found this group was more anxious than this group, less anxious, then I already have an issue, right? Because these groups should be similar, they should be comparable before I introduce anything to their environment, before I change anything in terms of their experiences. So if they're different at the beginning, then the two groups I'm comparing are not comparable, right? They're not similar. But let's say they were similar, okay? So no, they're about equal. These two groups are about equal. Great, I can move on. I introduce group A, or people in condition A, to the caffeine condition. People in group B, or condition B, to decaf. And then I find this difference, right? Then I find, well, okay, this group is anxious. This group is less anxious. So now I have a finding that shows the impact of caffeine. I don't have to worry about my design creating any flaws in my interpretation or leaving me open to any critiques based on my internal validity, right? Because these groups were comparable. And after my manipulation, I found a difference between the two groups. Now, if this group looked like this group at the beginning, then you have an issue, right? Well, I mean, if they were already stressed at the beginning, right? If you don't have that pre-test, so this is a flaw of the post-test. If you don't have that pre-test, people might ask you that. You're open to that critique. Well, how do you know they were comparable to begin with? You can say you randomly sampled, but if you say, well, we measured them beforehand and made sure that they were at equal levels of anxiety before they participated, then you have more strength to your argument. Okay, so now let's go over some advantages and disadvantages of each type of design. So the advantages of the independent group post-test only design is that you only have to measure once, right? So this is nice because it helps you avoid having the participant guessing what you're looking for, right? If you can imagine if you're asking for if you're asking about their anxiety before they participate, if you're taking some measure of their heart rate beforehand, they'll start kind of guessing what you're looking for, which might bias the data. The benefit of pre-test, post-test independent group design or independent group pre-test, post-test design is that it ensures that your random assignment was effective, right? It ensures that they're comparable, the two groups are comparable before you introduce your manipulation. Your manipulation would be the two levels of your IV, right? So that's the nice thing, right? You can say they're comparable. If somebody critiques you on that, well, you can say, no, I measured them beforehand and they were at equal levels of anxiety before my study. They were getting equal hours of sleep before I had them try my sleeping technique. Whatever it might be, you can make that, you have a stronger leg to stand on in that situation. It also allows you, this is kind of I think the best part, it allows you to see how much that DV changed, right? So in pretest only, in posttest only, you only see the end product. You only see, is there a difference in their anxiety? Is one group more anxious than the other? But if you have pre-post, let's say this is group A and group B, you can see, let's say as a bar graph, you could say how much it changed. Let's say, let me raise this a little bit. So you can say how much anxiety changed from here to here. And you could also see here, was there any change at all? If you only have post-test, you can't see that. You can only see, well, is there a difference in their anxiety level? So that's a benefit of pretest, post-test. You can see change before and after you introduce caffeine or your manipulation to the participant.